What's going on, everybody? Got another video here for you. This is finding a limit. It's the limit of x squared times sine of 1 over 4x squared as x goes to infinity. All right, so let's see what we've got here. All right, so looking at this limit as x goes to infinity, you can see this fraction in here. Well, the denominator is getting larger and larger, so that means this in here is going to infinity. Going to 0, and the sine of 0 is 0. And then x squared as x goes to infinity, that's going to infinity. So we've got infinity times 0. And of course, you know we can't do that. So we need to figure out a way to maybe rewrite this and possibly use L'Hopital's rule. All right, so this is equal to the limit as x goes to infinity. And what if I rewrite this thing like that? All right, so notice if you take this and you divide it, that's sine of 1 over 4x squared. So it's this divided by this, which is this times the reciprocal. You see, it's the same thing. Okay, it's just a different way to write it. Okay, so now let's look at this. X goes to infinity. So as x goes to infinity, of course, we just talked about this. This fraction in here goes to 0, and the sine of 0 is 0. And then as x goes to infinity down here in this denominator here, so as this x down here goes to 0, this fraction in the denominator goes to 0 also. So we have 0 over 0, which means we can use L'Hopital's rule. And so L'Hopital's rule says that we can write this as the limit as x goes to infinity of cosine of 1 over 4x squared. All right, derivative sine is cosine times the derivative of what you're taking the sine of. So what's the derivative of this thing? Well, I can write this as 1/4 x to the negative 2, right? This right here. And so if I take the derivative, that's going to be what? Negative 1/2. Well, I tell you, let's see, do we want to do it like that? Yeah, I guess we can. That's fine. Negative 1/2 x to the negative 3, which is negative 1 over 2. Now let's do it like this, which is negative 1/2 times 1 over x cubed. So that's times negative 1/2 times 1 over x cubed. All right, now let's look at the denominator. Well, what's the derivative of that? Well, 1 over x squared is equal to x to the negative 2. So this is going to be negative 2x to the negative 3, which is equal to negative 2 over x cubed. So that's going to be negative 2 over x cubed. All right. So there's the derivative of the denominator. And let me say this, I did this on purpose. Okay, we're going to actually erase this and do it a little bit different. But I wanted to do this on, I did this on purpose because notice how I did 1 over 4x squared, and I rewrote that as 1/4 times x to the negative 2, right? And what did I do? I did negative 2 times 1/4, okay? And that's fine. That's fine if you do that, okay? Nothing wrong with it at all. But let me show you this. Let's, instead of taking the negative 2 times the 1/4 and writing negative 1/2, let's just let's keep these. Let's keep the 1/4 and the x to the negative 2. Let's kind of keep them apart. That's one when we're taking the derivative. So that's going to be times negative 2x to the negative 3, right? So I'm not multiplying the negative 2 times the 1/4, but then we've got 1/4 times negative 2 over x cubed. Okay, so I mean, this is the same as this, but I hope you can see now why I redid it like this and didn't leave it like this. Because now, let's go ahead and replace this. And like I said, if you do it like what I had at first, that's fine. You're just going to have a little bit more work to do. But let's replace it with this. 1/4. So let's just rewrite it like this. Times 1/4 times negative 2 over x cubed. Do you see why I did that now? Because now, see how these are the same? They just cancel. Okay, you'll get to the same. You would get to the same answer if you did it the other way, but this is just easier. Okay, so this is going to be 1/4. I'm going to take this 1/4 and bring it outside the limit. That's the limit as x goes to infinity of cosine of 1 over 4x squared. And then what happens here? Well, as x goes to infinity, this fraction in here is going to 0. And we know the cosine of 0 is 1. And so we get an answer of 1/4. Okay? So what happens here is, yeah, you know, I did the derivative that way where I took the negative 2 and multiplied it times the 1/4. And once again, like I said, I did that on purpose to show you. So, you know, there's some times where you're working a problem and you do it, you know, you work it normal and everything. But then, you know, kind of look at it and say, well, but if I do it like this and rewrite it, you know, in other words, do the derivative like I did here, you know, if you come across something similar like that, just think to yourself, will that make it easier? Okay, is that going to make it easier to do? And so, you know, that's why I did it. But yeah, that's a problem using L'Hopital's rule. I hope it helped you. It's not too bad. So just make sure you go and check out my other videos. Hit the like button. Hit the subscribe button if you're not already subscribed. Check out my other videos. Give me a like, share, subscribe, and comment. And I will see y'all in the next one. Later.